we will see the third problem in this model. But of course, you have a slight change here. Let us see what is the change here. We are to evaluate integral 0 to 2 pi okay, cos 3 theta d theta by 5 minus 4 cos theta using contour integration. So in this case, what we do is, as usual, I take z is equal to e power I theta and d theta will be dz by iz, and your contour C is mod z is equal to 1. Okay. If you look at the numerator here, the numerator contains cos 3 theta. What I will do is, instead of rewriting this cos 3 theta in terms of z, now what I will do is, I will consider is z cube. Okay, because here I have cos 3 theta. Okay, because here I have cos 3 theta, what I will do is, I will write z cube. D theta will be dz by iz, and this will be 5 minus 4 into z squared plus 1 by 2z. Okay. So now what I do is, I don't replace cos 3 theta entirely in terms of z, right? Namely, writing it as cos z is cos theta plus I sin theta, z cube is cos 3 theta plus I sin 3 theta, and then writing cos 3 theta in terms of z power 3 and z power 1 by z power 3. I don't write like that. So instead of that, what I do is, I consider z cube, and at the end I will, when I equate the real part, I will have the value of this integral. Okay, and of course C is mod z is equal to 1. Okay, when I simplify, see in this this z squared and z cube gets cancels, giving you z squared in the numerator, and when I simplify this, I will have integral over C. Okay, now what will happen to this? I will have z squared dz by, okay, what will happen to the denominator? I will have z into, this will be 10z minus 4z squared minus 4, and this 2z will go to the numerator. Okay, so now what happens here is that I will have integral over C 2z cube dz by, I will remove this minus 4 outside. When I remove this minus 4 outside, I will have z squared minus 5z by 2 plus 1. Okay, and this 2 and 4 gets cancelled here, giving you 2 in the denominator. So if I take f of z as minus z cube by 2 into z squared minus 5z by 2 plus 1. Okay, so this will be your f of z. Okay, in fact I have left this I outside, so in this case I will have 2i. Okay, and similarly I will have 2i here. Okay, because here I have an I. So f of z will be minus z cube by 2i into z squared minus 5z by 2 plus 1. I have to use the Cauchy residue theorem here. So let me again rewrite f of z. Okay, when I rewrite f of z, I'll have f of z is equal to minus z cube by 2i into z squared minus 5z by 2 plus 1. Okay, this I can write it as minus z cube by 2i into z minus 2 into z minus 1 by 2. Okay, when I multiply these two, I'll have z squared minus 2z minus z by 2 minus 5z by 2 plus 1. Okay, now what will be singularities of f of z? Are z is equal to 1 by 2 and z is equal to 2. Z is equal to 1 by 2 lie inside C. Okay, it lies inside C. So now what will be residue of f of z at z is equal to 1 by 2. Okay, this will be limit z tending to 1 by 2. I'll have z minus 1 by 2 into minus z cube divided by 2i into z minus 2 into z minus 1 by 2. So z minus 1 by 2 gets cancelled here. So this will give you minus 1 by 8 divided by 2i. This will be 1 by 2 minus 2. Okay, so this will be minus 1 by 8 divided by 2i into minus 3 by 2. These two gets cancelled here. So you will have 1 by 24i. So integral over c f of z dz will be 2 pi I into 1 by 24i. This will be pi by 12. Okay, if you could remember, instead of cos 3 theta we took z cube, and what is z cube? Z cube is cos theta plus I sin theta whole power 3, and when you apply the De Morvis theorem, it will become cos 3 theta plus I sin 3 theta. So I have to equate the real parts. When I equate the real parts, we get integral 0 to 2 pi cos 3 theta d theta whole divided by 5 minus 4 cos theta. This will be pi by 12. So this completes the evaluation of the given integral.